Welcome back. Thank you for joining me. So today we're going to dive into the real 11 material, adding subtracting actual rational expressions, not just fractions. However, let's take a moment to just kind of review what this looks like. So, level 0 problem, non-algebraic. If we're just dealing with numbers, let's see what happens. Well, remember, the denominator ends up staying the same. So because we have 8 and 8, we just leave that 8 and just perform the operation in the numerator, 1 plus 3. The key here is to remember, if what you get can be reduced, do it. So 4 over 8 is really just 1/2, okay? So don't be afraid. You must reduce if what you get is able to be. So our next one, notice you have the same denominator, so I'm just going to put that right away. 4 minus 7 is a -3. And again, this can be reduced. Both top and bottom can be divided by 3, so we end up with a -1/3. All right, now a level 1 problem. This is now incorporating monomials in the denominator. Now notice, 2x and 2x, all right. We have the same thing down there. 3 plus 5 on top, that's going to give us 8. Now, looking at this, notice 8 divided by 2. 8 divided by 2 is just 4 over 1. So don't forget, when you can, you must reduce. All right, looking at our next one. Again, notice our denominators are the same today. So we have x there. Now, 5 plus x minus 5. All right, so looking at that, 5 minus 5, doesn't that just cancel off? We're just left with x over x. Well, what is anything divided by itself? Well, anything divided by itself actually just becomes 1. So that's how we fully simplify that one. We actually get something really, really nice. Now, moving on to the next step. So, level 2 difficulty problem. So here notice the denominators are the same. So we can just repeat that 2m minus 3. But now notice, with that minus, be very careful with how you're subtracting. What I would do is I'd put parentheses there, and then just like before when I taught you to kind of distribute that negative throughout, I would actually do that. So you remember that you are subtracting those things. So you really get minus a 3m minus a 1. So when you get that, negative 3m, 7 minus 1 is 6. And then the bottom doesn't change. So again, be very careful when you're subtracting that you're using those parentheses and kind of putting that negative throughout, that you're remembering that parenthesis or that negative distributes throughout. Looking at these harder ones. Now again, luckily, we still have a common denominator. So that 3x squared, minus x, minus 2 stays. Now again, we're subtracting, so I'm going to be really careful. I'm just going to put that throughout there. So I'm going to have 7x plus 5, and I'm going to actually write out minus 4x minus 3. So when I'm combining my like terms on top, 7x minus 4x leaves me a 3x. 5 minus 3 leaves me with a plus 2. Then the bottom, we have our 3x squared minus x minus 2. Now, something I want you to notice about that bottom, that is a quadratic trinomial. So I want you to be very careful when looking at that because you need to remember sometimes to reduce these, you're going to need to factor. All right? So for this one, it can actually be reduced. That bottom ends up factoring. And remember, quadratic trinomial means two parentheses. And again, the factoring is something that you should have down by now, that you should know. So I'm not going to spend time reviewing the factoring. I'm expecting that you know how to get that. All right? But the point is, when you factor it, now you can see you can cancel something on the top and the bottom. Okay? So by doing that, I have nothing left on top. When you have nothing, you can just put a 1 there. Then you have an x minus 1. So again, the key steps to these ones that we're doing now, these level 3 type problems, is the fact that you are now having to also factor. Now, I'm going to erase this, so if you need to finish writing down, make sure you pause the video now because I am going to erase this because I'm going to need some additional space for this next one. So this next one again, we need the same denominator, which today we have, and then the numerators we add. So x squared plus 4x. Now, notice both of these only have two terms. And notice on top, my variable is in both of my terms. So for the top one, I'm going to notice I can pull out that x. And I'm going to be left with that x plus 4. On the bottom, notice I can pull out a 5. And I'm going to be left with an x plus 4. So once you factor those, now you can see x plus 4, x plus 4. So all you have left is an x divided by 5. That is going to be your reduced fraction, your reduced rational expression. Our last one for the day. Again, notice our denominators are the same. The x minus 4 squared, so we can just leave that. And notice on top, we are subtracting, so we're just going to get that. Now we're going to notice that top is a quadratic trinomial. So quadratic trinomial means it's possible that it can be factored. So you should check to see if it can be. And again, I'm not going to spend time going over factoring. That's something that I assume you already know. So when you see that, you should be able to see you're getting 2x and x. To get that negative 4, you should be using 1 and 4, but realizing one of those will have to be negative. So the right combination is going to be 2x plus 1 and an x minus 4. On the bottom, what I want you to recognize, the x minus 4 squared is really just giving you 2 of those x minus 4s. Cool thing about that is now you can slash off one of the pairs and you end up being left with 2x plus 1 and x minus 4 to end your problem. So, thank you so much for joining me. Please make sure you have all of this written out and you come back to class prepared to begin our practice work. Thank you for joining me for the second piece of this 11-4. We're still working on adding and subtracting these rational expressions, but today we're going to dive into unlike denominators. What to do when the denominators are not the same. Now, before we dive into that, a little bit of review. What do we do when they are the same? Well, that's the nice case where we leave the denominator, so x squared minus 9x plus 20. And now on the top, we simply do that subtraction, 3x minus 12. Now the important piece of each of these, once you actually do that, now you need to factor to see if it reduces at all. So on top, it is a linear expression. For linear expressions, all you can do is pull out a greatest common factor. In the denominator, we have a cubic or a quadratic trinomial. Quadratic trinomial is going to mean setting up our two parentheses. We're going to get x and x, two things that multiply to 20 but combine to -9. That's going to be -4 and -5. So now notice, when you do this, now those x minus 4s can actually cancel off. Now I'm out of space, but what you're left with is 3 over x minus 5. So that's a little review of our previous notes. Now, what we're going to look at today, starting with level 0, which is no variables, is unlike denominators. Now remember, for these unlike denominators, what I always did is I split up what the denominators were. So 6 is 2 times 3, and 8 is 2 times 2 times 2. So I need to look to see what is each one missing. Well, that 6 is missing a 2 from that 8. So I'm going to multiply top and bottom by 2. Actually, I'm sorry, the 6 is missing 2 2's. Okay, so the 6 needs 4 over 4. The 8 is missing the 3. So I'm going to multiply top and bottom by 3. So that's what we end up doing for these, is write out what each number is, how it breaks up, and then see what is it missing from the other number. So here, that first fraction, you end up getting 20 over 24. The second fraction, you end up with 3 over 24. And remember, the bottoms stay the same, so we just get 17 out of 24. All right, level 1, let's begin introducing some variables. So, level 1. So here, these break up relatively easily. So 2x is just 2 times x, and 5 is just 5. So this may seem a little bit silly to you in this case, but it's a good habit to get into because it'll help you later on when it comes to level 2 and level 3 problems. So what is the 2x missing? Well, the 2x is missing 5. And what is the 5 missing? Well, the 5 is missing 2x. So I'm going to multiply by top and bottom of whatever it is missing, because by doing that, that is going to give me a common denominator. So the first one is going to give me 15, and then 5 times 2x is 10x. Then the other one is going to give me 2x over, and again, 2x times 5 is that same 10x. So when I write this, now I'm going to put this in standard form. So instead of 15 plus 2x, I'm going to call it 2x plus 15. But then remember, now that we have that common denominator, that denominator stays the same. And so that is what we end up getting. All right, let's look at our level 2 problem. So again, it may seem a little bit silly in this case, but it'll help you later on. So the 3 is just 3. 4x is 4 times x. So what is the 3 missing? Well, the 3 is missing 4x and 4x. All right, so again, you multiply what it's missing by top and bottom. Now, what about the 4x? Well, the 4x is missing a 3. So you multiply top and bottom by 3. So what you end up getting, you take that first one, 4x times 4x is 16x squared. 4x times 3 is 12x. Our second parenthesis, 3 times 3 gives us 9. 4x times 3 gives us that same 12x. Now, if you do this and you don't get a common denominator, that means you did something wrong and that you should go back and re-look at what you multiplied by, okay? So here we get 16x squared minus 9 over that 12x. All right, so that is a level 2 problem. Let's dive in to the next difficulty, level 3. Now this is where it starts getting a little bit more meaningful. Why I'm having you write this out. So 2x is 2 times x. 3x is 2 times x times x. So now when it comes time to see, what are we missing in each of these? So what is a 2x missing? Well, it's missing a 3 and an x. So that's what we end up multiplying by. Now what is the 3x squared missing? Well, the 3x squared is only missing a 2 from the other one. So that's why this becomes more meaningful, because here it helps you see more of what you need to multiply by. So let's take a look at this. So 3x times 1 is 3x. 3x times 2x is 6x squared. Now I'm adding, so now 2 times x plus 1, okay? So 2, and it's multiplying the x plus 1. So I'm going to think of that as distributing, okay? I'm going to distribute that out. So I'm going to get 2x plus 2 from that. Then 3x squared times 2 gives us 6x squared, which again, we know we should be looking for because we need that common denominator. So it's a good thing that we got it. So now it's always over that same denominator, that's 6x squared. 3x plus 2x combines to 5x. And then we still have that plus 2, and that is going to give us our answer in this case. All right, now our level 4, the most difficult type of problem. This is where, again, it is the most meaningful to actually write out what each of these becomes. Because now notice we have 3 things we're adding. So here, this is 6 times a. This is 3 times a times a. 3 times 3 times a times a times a. And I realize I actually made a little mistake here. So 6 actually breaks down into 2 times 3. So you want to take it down as simplified as possible for each of those denominators, okay? Now the reason we're doing that is because we need to see what are we missing in each piece. So the 6a, what is the 6a missing? Well, you can see from that 9a cubed, it's missing a 3 and then 2 a's. Okay? So the 6a, notice, is lacking a 3 and 2 of the a's. So that's where that's coming from. Now, when looking what the 3a squared is lacking, it's lacking a 2 from the a, and then, or a 2 from the 6a, and then one of the a's from the 9a cubed. So here we're getting 2a over 2a. And what is the 9a cubed missing? Well, that you can see is only missing a 2 from the a. So we get all of that. And now it's time to start multiplying it out. All right, now I'm going to extend my page a little bit because this is going to take quite a bit more space. So 3a squared, and I'm multiplying it by a minus 4. So I'm going to have to distribute that to both of those. So that's going to give me a 3a cubed minus a 12a squared. And then the denominator, 6 times 3 is 18. A squared times a is a cubed. Our second one, 2a times 1, is just 2a. 2a times 3a squared. Now, actually, if you notice, I inadvertently made a mistake here. Because that 3, not only is it missing the 2 from the a, it's missing an additional 3 from the 9. So it's missing a 2, a 3, and an a. So actually, if you would go back, fix that to be a 6, please. So we're going to get 6a on top. And again, when I got to the denominator, that's how I could tell I did something wrong. Because as written, it wasn't going to give me that right denominator. So, nice check. Again, even I can make mistakes, but if you notice how I picked up that I made one, that I should be getting that same denominator everywhere. Okay? And now, this last one, again, I'm going to distribute that. So 14 minus 6a. Then 2 times 9a cubed gives us the 18a cubed that we know we should be getting. And from here, now we have to, unfortunately, simplify all of this. Now that we have our common denominator, that 18a cubed is going to stay. And now I'm just going to combine my like terms. So I have 3a cubed, and there's no other a cubes on top. I have a minus 12a squared, and notice there's no other a squareds on top. 6a minus 6a actually ends up canceling itself, and then plus 14. All right, so I realize, again, towards the end, getting to some beastly problems. However, please make sure you have all this written down. Please come back with questions for things that you didn't understand from the video so we can discuss them in class together. So thank you for joining me. Come back prepared and we will do our practice work in class.